Hey guys, these are our notes for piecewise functions. So we're going to be on slide 17 through 19. At the top of your paper, you can go ahead and put your title and then write piecewise function. So basically what a piecewise function is it's a function that's made out of multiple pieces. So you have to have at least two pieces, and it has to be, each piece is only over a certain domain. So it's just a function made up of at least two pieces each with their own domain. So something you're going to see on the graph is you're going to see some like open and closed circles versus open and close, less than, greater than, that kind of thing. So if you see an open circle, your open circle means that those values are not included. That'd be like parentheses. If it was an interval notation, it's going to have a less than, greater than symbol. If you see a closed circle, that means that those values are included. It'd be like a bracket, or where it has the or equal to symbol underneath. All right, so you're going to have to draw this little example. It says identify the domain of each function. Okay. All right, so go ahead and draw this little graph as best as you can. And then what we're going to do is identify the domain. So normally the way that it's written is it says f of x equals, and normally they put like a little brace like that. And then they put whatever the functions are. So this one has three distinct pieces, right? Three separate pieces. So what we're going to do is we're going to identify like which equation goes with it, and then we're going to identify the domain, which is your x values. So what we know, normally the way that it works is it goes like from left to right. So like the parabola looking one is the first one on the left, so that's your x squared, and that does match up. So normally we go from left to right. So that is an x squared because it looks like a parabola. Then this one's just a line. See how it's just a horizontal line? That one's always just going to be a number. And then we have a regular line right here. That's just line x. So that one's here. All right, so here's how we tell the domain. So to tell the domain is you're going to have like x's in between certain numbers, okay? So you're going to have x's in between certain numbers. So you can kind of start off by just putting like x's in between and then certain numbers. And then we'll decide if it needs to have a line underneath, if it's closed, if it's open, we'll just leave it as that kind of symbol, okay? So on the end of these, even though there's not written, there's technically like arrows on each of these ends because there's no points. So what we look at is this blue one, okay? We look at the x values, okay? So this x value right here is a 1. And then this way it just keeps going. The arrow just keeps going. So in this direction, you're heading towards negative infinity. So the x squared is between negative infinity and 1. Infinity will always just be a less than or greater than symbol. You'll never have a line underneath it. But notice how this point right here is closed. So we're going to put a line underneath it for the 1. And then my next piece, okay, this yellow piece right here, you're looking on the x-axis, always the x-axis. So you just kind of go from your points and you go straight down. This point is also at 1. This one right here is also at 1. And then this point over here, if you go straight down, is at 2. So for this yellow piece, it's between the domain of 1 and 2. Well, this is an open circle at 1, so it's just going to stay. But this one right here is a closed circle at 2. So this one is going to put a line underneath it. And then my last piece, you just go from your circle, you go down. This is at the number 2. And then this one has an arrow. This one just goes on forever. And this side is positive infinity. And then you can see this is an open circle, so we're not going to put a line underneath. And then infinity never gets a line underneath as well. So the way that it works is that each little function gets its own domain. The domain is the x values. So you just kind of go from whatever the endpoints are. You look at the endpoint and then you just go straight to the x-axis, either up or down to the x-axis, wherever you are. And you just see what numbers are there, and then that's what you use for your intervals. They could put them, normally I think all your homework problems, like on Delta Math, I'll write it this way. You could have it in like interval notation where it'd be like a -infinity, comma 1 with like the bracket, but all of the homework one just has it written as the inequalities. All right, now we need to grab our workbook for our examples. This is in workbook 4B. We're skipping quite ahead. It's page 117. This is unit 4B.4.2. And we're just going to do two examples. So example 1 says a wholesale store sells paper plates for $3.27 per package, up to and including 50 packages purchased. If a customer buys more than 50 packages, the price of the entire purchase drops to $2.73 per package. Write a piecewise function for this pricing structure and determine the price the deli owner would pay for 75 packages of plates. So piecewise function is made up of multiple pieces. So there's two options. Either you go to the store and you buy your paper plates for $3.27 per package, up to and including 50 packages, or if you buy more than 50, then the price drops to $2.73 per package. So we have two different functions. So the first one says write a function for the price paid for 50 or fewer. So up to 50, you get a certain price. So that function is just, f of x equals, okay, and then it's $3.27 per package, so that's your slope that gets attached to your x. There's no y-intercept, there's no flat fee or anything, so it's just $3.27x. Then it says to write an equation if you have more than 50 packages. So if you do more than 50 packages, you pay $2.73 each. So this function would be f of x equals $2.73 per package. So that's your slope. That's the one that gets attached to the x. And then there's no y-intercept because there's no like flat fee. And then it says right here to combine the two functions to show the two pieces. So the way that it works, we have two different functions. When we put them together, we write f of x equals, and then we make like a little bracket. That wasn't very good. I think that one's called a brace. And we put 327x, comma, and then 2.73x, comma. And then over here, we need to write their domains. So when do you use this function right here? Well, you use this function if you get 50 or fewer packages. So this one would be 50 or fewer. So x has to be less than or equal to 50 because it says including 50. So that one's less than or equal to 50. When do you pay $2.73 per package? If you get more than 50. So x has to be greater than 50. It's not including 50. You have to have one can be open. You can't have both of them closed circles because if you get exactly 50, you can't have the line underneath here because then you wouldn't know which one to use. All right, then it says calculate the price paid for 75 packages of plates. So here's what some of your homework is going to ask you. It's going to ask you, it's going to say it like this, but basically it's saying find f of 75. So you have to figure out which equation do you use. Do you use the top equation or do you use the bottom equation? So you look at, okay, the number 75. Is 75 less than or equal to 50 or is 75 greater than 50? Since 75 is greater than 50, that means we're going to use this equation right here. So we just plug in 2.73 times 75 and you get $204.75. So on your homework tonight, it's going to give you a function like this. It's going to give you like find f of a certain number. So you have to decide which one you use. You don't use all of them. You decide which function you plug it into. So I plugged it in for x here in the second equation because 75 is greater than 50. All right, then a couple of your homework problems, you have to write equations for a piecewise function. It says when heat energy is added to ice, the temperature less than the freezing point of water, the heat goes into raising the temperature of the ice until it starts to melt. When the ice starts to melt, all of the heat goes into melting the ice, not raising the temperature of the ice-water mix. After the ice is melted, the heat goes back into raising the temperature of the water that results from the ice melting. The following graph shows these three distinct phenomena. So when you have ice, the temperature goes down until all of the ice is melted, until it becomes an ice-water mix, and then just stays the same temperature. And then once all of the ice is melted, that's when the temperature of it starts to raise. So those are the three distinct pieces. So it says, in this situation, the heat energy is mixed into ice such a way that can be described by a quadratic function model. So this piece is quadratic. That's x squared. The ice-water mix parts of the heat temperature function and graph are linear functions. So these two pieces right here are linear. So we have one quadratic and two linear pieces. It says use a graphing calculator to derive a function for each of the three parts of the piecewise function, then write the complete function and its domain. So we're not going to have to use a calculator. We're just going to do it by hand. So yesterday we looked at how to write the equation for a quadratic function. You need 2 points. You need the vertex and then any other point. So here's our vertex, because the parabola would look like this. So we only have half of it. That's the point 0, negative 25. And then we have one other point up here. This is the point 40, 0. So this quadratic equation, right, quadratic function looks like f of x equals ax minus h squared plus k. We need three things. We need a, h, and k. Those are the three things we need. Well, we already have two of them. We have h and k because that's the vertex, and then we have another point which is xy. So we're going to plug in hk, xy into this function, and we're going to solve for a. So f of x is y, so that's 0. So I get 0 equals a is what we're trying to find. That's h. X is 40. Minus h is 0. Squared plus k is negative 25. So plus a negative 25 is just minus 25. All right, now I'm just going to go ahead and solve for a. So I'm going to add 25 to both sides. I get 25 equals a times 40 minus 0 is just 40 squared. 40 squared, 4 squared is 16, and then you just add in 2 zeros, so it's 1600. Divide both sides by 1600. And I get a equals 25 divided by 1600. I'm going to simplify that fraction. You could technically make it a decimal. I'm just going to simplify it as a fraction. 25 goes into 1600 64 times, so a is just 1 over 64. So the equation for this blue quadratic function right here is just f of x equals, and then a is 1 over 64, parentheses x minus h, which is 0. So I don't even have to write that. I'm just going to write x squared, and then minus 25 because it's plus k. So that's the quadratic piece. Now let's go ahead and do this linear piece right here. So anytime it's just a horizontal line, your equation is just going to be a number. That's all it's going to be. So whatever number it is, whatever number you hit the y-axis at, that's your number. So this equation right here, it's just a horizontal line at y equals 0. So f of x equals 0. That's the equation for that yellow piece. And then my last one is that green one, and this is just a linear equation. So I have 2 points here. This point is at 120, 0, and this point is at 140, 30. So we're just going to use these 2 points, and we're going to write the equation of the line, which we did. It was on your test quiz that you had last week. So first thing you're going to do is find the slope using y2 minus y1 over x2 minus x1. So it doesn't matter which point is point 1 and point 2, but this one came first. I'm going to call it x1, y1. This one's going to be x2. y2, so y2 minus y1 over x2 minus x1, I get 30 over 20, which just simplifies to 3 over 2. So my slope here is 3/2. And then I just have to go ahead and find, so it's y equals mx plus b. I need to find b. B is the y-intercept, but I can't see like where on the graph it's going to hit the y-axis. So I'm going to go ahead and do... we're using y equals mx plus b. I'm going to use any one of the points. It doesn't matter which one. I'm just going to use this point. Well, there's only two. You have to use one of those two. So y is 0, m is 3/2, x is 120 plus b. 2 goes into 120 60 times. 3 times 60 is 180. So I'm going to subtract 180 on both sides. And I get b equals negative 180. So the equation of this line right here, we get f of x equals, move that over a little bit, f of x equals, and then y equals mx plus b. So 3 halves x minus 180. That's a 3 on top. All right, so now that we have our 3 equations, we can go write our function. So our function is f of x equals, we have 3 pieces. We want to go in order from left to right. So my first piece is the function 1 over 64x squared minus 25. The middle one is just 0, put commas after. And then my last one was 3 halves x minus 180, comma. Now we need to go ahead and find our domain. So that's what our x's are in between. So I always just go like this to start. And I put my x's in between. And then I just look at my x values. So on this blue piece right here, okay, you look up at the x-axis. So my x-axis is at 0 and my x-axis is at 40. So 0 and 40. There's definitely a closed circle here. That one's a closed circle. I don't know if it goes with, like which piece it technically goes with. So I'm going to put the line underneath it. And we're just going to use the closed circle for the quadratic piece. And then my 0, okay, that's the yellow one. It goes from the 40 all the way to the 120. So the yellow piece goes from the 40 to the 120. I'm just going to leave that one as just both open circles. So I'm not going to put the line underneath. And then that last green piece goes from 20 or 120, and then the last piece is at 140. So I'm going to put 120 and 140, and then we'll put the closed circles on both of those. So the 40, okay, there's 2 40s. Only one of them can have a line underneath. There's 2 120s. Only one of them can have a line underneath. So I just did the closed circles on the blue piece and the green piece, and then the yellow piece I did open circle, but it's not really clear like which one the open circle would be to. And that's our equation. These notes are going to go in on slide 17, which has the wrong image, I'm sorry, and then slide 18 and slide 19. Then your homework is on Delta Math.